All right, group 7. A cannonball is shot upward at some angle. The graphs below track the vertical and horizontal velocity of the cannonball during the first 8 seconds of its flight. So we're not seeing the entire path of these objects. We're only seeing what happened to the vertical and the horizontal velocity during the first 8 seconds. So the first part says, what was the vertical component of the cannonball's initial velocity when it left the cannon? And again, since we know that we are dealing with something shot at an angle, there is an initial vertical velocity, right? It's only 0 when it's a horizontally launched projectile. All right, so first I'm going to, since this question is asking about the vertical component, I'm going to look over here at my vertical velocity graph. And initially would be at time 0. So at time 0, if you look here, what was the initial component, vertical component of the velocity? And it would be 80 meters per second. Okay, so I don't have to calculate anything. I'm just simply reading that from time 0 on my graph. Okay. B says, what was the cannonball's initial velocity, which is the resultant? Resultant is like the hypotenuse of a triangle. Okay, so that means that we need to now utilize both of these graphs. So we know that vertically it was 80, so I'm going to draw that in. What is the horizontal velocity, the initial horizontal velocity? So I'm going to come over here to time 0, and we can see that it's actually a flat line, which means it always has the same velocity. But if I come over here to time 0 and I look there, I can read the value, which is 100. Okay. So there's my x component and my y component, and I'm going to put those together to find the hypotenuse, or the resultant. Okay, so that means that I have 80 squared plus 100 squared equals c squared, the hypotenuse squared. So 80 squared plus 100 squared is 16,400 equals c squared. Now remember, make sure you don't stop here when you take the square root. So the square root of that is 128 approximately. Okay. The last one says, at the top of its trajectory, what will be the cannonball's velocity? So this is similar to our last question. Imagine that we have the trajectory drawn out. Okay, and we're looking right here at the top. So at the very top, what will become the vertical velocity? Well, the vertical velocity we know is going to be 0, right? That's at the point when it's no longer moving up or down. But it is still moving to the side, right? And so it still has its horizontal velocity, which stays the same all the time. So if we look at our horizontal velocity, right, all the time, it was 100 meters per second. So what do you imagine it is right here? Well, it's pretty easy. It's also 100 meters per second. So Vx is 100 meters per second. At this point in the path, that is the only velocity that is left, right? At the very top, all that is left is the horizontal velocity. And so what will be the total velocity, I'm going to just call it V, total at top, is equal to the horizontal velocity, which is 100 meters per second.